Alright, so in this video, we're going to be going through the overview of microprocessors. So before we begin, I'll just give you a quick and brief description of how exactly any computer works. So in your computer, you're going to firstly obviously have something known as your processor. We're going to just draw a square there and denote it by P. You're also going to have two other main things, which is going to be your RAM and your ROM, which is going to be much bigger than your RAM. It's going to be way bigger than your RAM. And essentially, these three are your main things which you need to run any computer system. In your processor, you're going to have billions of these tiny little things known as transistors, which are going to be connected. And when you say a computer functions with like the language used by computers is zeros and ones, essentially what you mean, or what that physically translates to, is a low voltage value or a high voltage value, 0, 1. So the low voltage value is 0 volt, and the high voltage value in most cases is 5 volts. Some cases can also be 3.3 volts, but yeah, any computer system, any digital system, that's what's happening. So even if you see something which is like very continuous or smooth, that's not continuous or smooth. That's actually, if you break it down, it's going to be tiny sets of zeros and ones which are happening in some particular fashion to make it seem continuous, but it's not exactly that way. So now suppose you're opening any application, suppose you're downloading any application, suppose you're downloading Microsoft Edge or Google Chrome. You're going to be downloading the code which is written for that browser onto your RAM. Now, when you want to access that, what exactly happens is you give an input, like you use your mouse, you set it onto the Chrome icon, and then you select it. Basically, what happens is when you set your mouse on there, this guy, the processor, goes to the ROM, and now imagine the ROM as like a big shelf with a lot of items on it. So what you're going to be doing is finding the thing you want, which is Google Chrome in this case, and you're going to move it to your RAM. The reason for that is, suppose you're in a library, or suppose you want to read one particular page of some particular book. You're going to go to the library, find the book, take the book, sit down, and then find that page. Suppose you want to read like 10 pages from that. You're going to read that one page, and then you're just going to finish reading those 10 pages and put it back. It's not going to be like you go, you find the book, sit down, read one page, then again put it back, again go and find the book. No, you're not going to do that. That's essentially what moving the software to the RAM does. You're bringing the book off the library to your table to read. Then anything you do with the application, any application, you're just interacting with the RAM right there from the processor and getting your work done. That's basically how a computer functions. So this is some important block diagram as such. It's a basic block diagram of any computer. So one thing you'll notice here is the CPU has several parts to it. By the way, if you see something like that, that means micro. So when you write this, it's just basically microprocessor, microcontroller. That's a microprocessor control unit. Now let me give you an example. Suppose this is me. I give you a set of instructions. This is you. And you're going to listen. So basically I tell you, all right, I want you to go to some place, find some books. Let me write that down. Find the books and move them to another floor and rearrange. Suppose I tell you to do that. Now, me giving you these instructions is going to be what the job of the microprocessor control unit is. It takes the input from the input device, breaks down the instructions. And similarly, when you're producing an output, the microprocessor control unit comes into play again. So now, this order is known as the program order. So you're going to be listening to all of this, right? These are like instructions which are going to be stored on your register, which is like, imagine this to be a part of your brain. Imagine this is your brain. One tiny part of your brain is going to store all of these instructions. Now, the rest of your brain is still there because we're going to be using that as an ALU. What is an ALU? Arithmetic logical unit. So First of all, let me finish the program order thingy. So all this thing is the program order. This is the order in which I want you to execute these programs, these tasks. Now, there's also going to be something known as a program counter. What does a program counter do? Essentially, it's going to point to the next instruction. Excuse me. So suppose before I tell you anything, the first instruction I told you was find the books. Then before you've done this, the next instruction would be this, right? So the program counter is going to tell you, all right, do this. Once you do that, it's going to point to the next instruction, which is move the books. Next instruction is going to be rearrange the books. So that is what the job of the program counter is, to point to the next instruction to be executed. You'll understand this better when we look at some codes. So yeah, essentially that is the concept of the program order and the program counter. Now, once I tell you all of this, I'm just the microprocessor control unit. I'm just going to tell you, you're going to use your own brain to find the books, move them, and rearrange them. Your brain works as the ALU. You have your own independent processing capabilities. Suppose there's an instance where I also tell you that each book which you move, I want you to read the entire book, the context of each book, and memorize it. All of that information is going to be stored in your memory. This is the basic functioning of any microprocessor. So in the exam, usually in Cat 1 this is asked. This is something which is very important. But if you write this exactly this way, each teacher is going to eat it up. You're going to get good marks. So this is very important that you write that. This question, you just have to remember PCRE. The way I remembered it was professionally cooked random eggs. I have terrible memory. I used to come up with all sorts of most random and ridiculous mnemonics, but that worked. And I think, if it's a good technique, why not? So yeah, just remember that you're going to easily get 2 to 5 marks if you write this definition exactly like this. This entire highlighted section is quite important. Yeah, one more thing which is important is fetch, decode, and execute. Make sure that these sets of words are visible in your answer, because every faculty is going to look for this. Fetch, decode, and execute. What does that mean? Me telling you to get the books, that is you fetching the instructions. You understanding what this stuff means is you decoding those instructions. Then you going and doing all of this is basically your execution of those instructions. So yeah, that's how fetch, decode, and execute works. And obviously this is standard, this is just something you need to know and memorize. Like, it's pretty obvious, right? You want your microprocessor to be cost effective, small size, low power consumption, highly versatile, and obviously very reliable, something which doesn't have too many faults, etc., etc. Applications of microprocessors, essentially anything which you can see which has some sort of toggle, some sort of control, it has a microprocessor in it. Every single thing you see has a microprocessor in it. That's just something you're going to need from the exam point of view. This is an important diagram. It's either going to be this or the 8086 architecture, which they can ask for CAD 1, at least it used to be that way. So how exactly does it work? Primarily, I'm just going to tell you how I memorized it. You can come up with your own way. I just remembered, like, okay, I just drew a 3x3 box matrix like this. Then I broke the top left corner into 2. Then I just remember that, okay, in the diagonals, I have to add 2 boxes. And once I did that, I remember that there was a big box on the left, which is the microprocessor unit. And then I remembered OIO, out, in, out. So this thing is something which is available in the outdoor world. This is a timer. Well, each processor has something known as a clock. Basically, each instruction which I mentioned to you, it needs to be executed in a sequential manner. Everything your processor does needs to happen in some sort of order, some sequential manner. How do you control something, or how do you help something follow a sequence? You use a clock. So I just assume the timer to be a clock. It isn't in this case, but it is easier to remember it that way. And then again, this is something which interacts with the outside world. So yeah, one more thing is 2 input ports, 2 output ports. Just remember it that way, and I think you'd be sorted. And the rest of the content in this is essentially just about theory of microprocessors and microcontrollers. Not too important, but occasionally either the morning set or the evening set can get the question regarding from this part. Well, you know, one set will get the question about what exactly a microprocessor is and stuff like this. One set can get the question about the theory of the stuff. It's just essentially you just have to read it. There's nothing much to it. In the next video, we're going to be going a bit more in depth and possibly starting with the 8086 micro.